Okay, so that brings us to exercise 11.7 about bacterial growth. So in this exercise we're going to work with some of the files we saw earlier in exercise 8. So in exercise 8 we were given a list of files here, and we can see that quite a lot of them, there are actually 160 files because they start at index 0. And what we want to do here is that we want to load these files and put them into a NumPy array for later use. So you can imagine each file contains a 1B time series, and there are 160 of them, so we'll put them in an array which has 160 dimensions vertically, and then as many dimensions as there are points in the time series horizontally. We're given a bit of help here, so I'm going to copy paste that. And if you go here to the bacterial growth, we need to implement this function that does the loading. So what I'm going to do here is I'm going to insert this little if statement in the bottom, because I only want this code to be run. This is going to be my debug code. I only want it to be run when I run the file and not when the tests import the function to be tested and run it. That will be a little bit confusing. So what do I want to do here? I guess I want to call the function. It doesn't take any arguments, and it returns the data. And then maybe I just print out the shape of this data matrix. So actually maybe I don't want this code here. I want it inside the load data function. That looks like the relevant place. And in order to get started, I'm going to insert a line and a breakpoint because I want to do this in the debugger. So with that being set up, I can run the file in the debugger, and what's going to happen is that it's going to call the function here, start running the function, hit my breakpoint and stop. Okay. So here's some interesting code. Okay, actually I want to, maybe what I want to do here is that it has a for loop. We know what that does. It defines a file name. We also know how that works, and then it does this stuff here. And this we haven't seen before, I think. So let's just call this for x. Let's store this for later reference, and let's actually put a breakpoint here. So I'm going to remove this breakpoint and restart my script because I want to run it until this point. Okay, so what does this line do? Let's just try to look at it. I go in the debug console, and the file name is this, I is this, and this line will load the data in that file and give it as a NumPy in the array. So you can see this is a special NumPy function. So these x's have 12 elements. So the data that I want to return should actually be an array of dimension 160 and 12. So I'll initialize this data matrix first. So like 160 and 12, like this. Now that I load, so let's just run this initialization code once. So now I got A, and I got X. And then what I want to do is I want to assign the first row of A, which is right now all zeros. I want to assign that to X. And I can just do that with the syntax that we saw in one of the introductory exercises. So now A has been updated and the first row has been set. And then of course, when I run the loop more times, I want to update the ith row. So what I actually want to do here is that I want to do this for each I, like this. And I think that should do the trick. So let me select all of this code and Shift Alt E, run it. I could also just copy paste it in here. And now A should be appropriately updated. And I think this looks fine. We can see that all the data sets are different, so it's actually doing something different for each I, and I guess it's doing the right thing. So let's return A and be done with that. Okay. So I'll stop the debugger and let's go to the tests and check that this works. So as you can see, I got a coughing fit. first time I did this exercise, so it was a little bit like, annoying. But that brings us to the next one, threshold exceeding. So what this one is doing is that we imagine that we have all of these 160 time series, and then we're given a threshold, which is a number. And then what we want to do is for each time series, we want to figure out what is the first time it exceeds the threshold. And then we want to get the element in the time series, like the index. Like so does it exceed it at time point 4? We want to get that index. And then we want to store all of these indexes in a new area and return that. It's a little bit confusing to say, but I think it'll become easier when we start working with the exercise. And we should solve this without loops. Oh joy. Okay, there's no getting around it. Let's try to just get started. So we'll first try to we can see these elements they start at around 1 and they end up with a big number. So a good value of the threshold to try would maybe be 2. So let's try to call this function. I'll give it the data set and I'll give it a threshold value of 2, and that'll return something. And then let's just print that something out. I just want to call the function because I want to insert a breakpoint. So here's the function, and we insert a breakpoint here. And let me start running it. Get to the breakpoint. And now we can see that we have the data and we have the threshold value of 2. And this is where we need to get the good idea. So how are we going to solve this? So the index at which the threshold is exceeded, I guess that's the first time point where the threshold is exceeded, because it could be exceeded multiple times. So it's the first time it's exceeded. So let's look at the first one, just to get an idea about what this problem is doing. So the first experiment, we can get the data like this. And then we can see it's not exceeded here, it's not exceeded here, it's exceeded here. This has index 2. So in the first case, we should return 2. If the threshold had been 4, it would be exceeded here, so we should return 0, 1, 2, 3, 4. We should return 4 in that case. Okay. There are 2 general strategies for doing that. The one strategy is you could try to be really smart and do this in one line in NumPy, and the other strategy, which I think is a little less ambitious, but it has a greater hope of succeeding, is you just try to solve it using regular Python, and then once you have a basic solution, you try to think about how you can do it with efficient NumPy code. Regular Python solution. This is the data for the first experiment. We call that x, right? So how would we solve this exercise? Well, maybe we would have a for loop. So we loop over all the time points of x, right, like this. So if I run this code, it just loops out these things. So we can get what x is at time point j, and we can get j like this. And then we can test if the threshold is exceeded. Like this. And I'll also print out what j is, I guess. And then if I run this code, you can see that it prints out 2. That's the one I want to return. So what I can do here is I can break the for loop. So when I have the break keyword, it will break this for loop. Now when I run it again, it just prints out 2. And that means that I can send the value, the correct index was j. I'll remove this because it's a little bit annoying. Again, it should be here, because okay. So what was the problem here? here I'm like testing this condition, and if the condition is not met, this is not executing, then it prints out this. That means it printed out 0, condition was not met, and then in the second step it was not met either, so it printed out 1. And then for j equal to 2, it was larger than the threshold, so it broke and didn't execute that. That was actually exactly what I didn't want it to do. So I should put it down here, because it's once the for loop is completed, like when x of j is larger than the threshold, stop the for loop, and then I can get the whatever value j was here. This is what I want to do. And again, like, just observe, this is a lot easier to figure out in debugger, because you can just experiment with your loops and your code and see that you get the right values. So now I got j. Let's stick that into an array. So let's call the array for b, and then say b.append j. So we update b, and that was for the first experiment, so we should loop for all experiments. So let's have another loop. Data.shape of 0. So this is how we can get how many experiments there are. Like, we can access the shape. That's a tuple. First element of the tuple is the 160. So this will be a loop over all the experiments. And then I just indent all of this stuff. And I use I here. And I don't want to reset b, because b is the indexes that I eventually want to return. And now it's looking like something, I think. Now we got all of them. It's like Pokemon. And now we not just need to turn this into a NumPy array. So we can do that using np.array of b and just return that. And that is like, that's not the intended way of solving it. So we'll get to the intended way of solving it in a second. I just want to confirm that this actually works. So let's stop the debugger here. I think we are happy with this code. Go to run and run it. And it worked. Okay, so this is how we would do it with like absolutely minimal use of NumPy. I'm only using NumPy for indexing, and I have 2 for loops. And if this data matrix was like much bigger, and I needed to do this in milliseconds, this would not be super efficient code, although I think this code has some advantages to what I think the solution should actually be. Because how would I solve this with just using highly efficient NumPy? Let's try to look at that. So I'm going to insert a breakpoint, and now I'm going to insert it up here, because now I want to not be guided by what I do down here. I want to start over again with pure NumPy. So I think I need to use argmax. Yes, we need to use argmax. So what is argmax doing? Let's say we create a NumPy array, np.array, and let's say it's -3 and 2 and 1 and 5 and 4 and -2 again, like this. If I do argmax, it returns 3. Why? So what it does is that it finds the maximum of this array. That would be the 5. And then it returns the index. So it's like 0, 1, 2, 3. And therefore it returns 3, because it is on the 3rd index. Okay. So now an idea could be that I take data, and then I could look at like ideas revolving around argmax. Because I want to find like where it exceeds a threshold, and that's kind of has to do with a maximum. So let's try to do argmax of this array. So that just returns that means that if I consider all of these like linear index, so like 1, 2, and so on, and then it starts over here like 13, 14, 15, and so on and so forth. The index of the absolute maximum element is 611. You can actually figure out what also it's linear index, of course. So it's a little hard to figure out exactly what this corresponds to with what we know so far. But just trust me, this is like the absolute maximum element if we consider all of the elements as one big array. That's not quite what we want. You can pass a dimension argument to argmax, and you just need to know this. And we can see actually that when I pass the dimension argument, it just gives all 11s, and that's because it's always the last elements that's the largest value. So we can actually here observe, maybe I should have noticed that before, that the lists are always growing. So that's why the argmax will now like look at the argument maximum for each row because of the 1, and that'll always happen at index 11. It always happens at the last element. Okay. So now we are interested in the elements that are bigger than the threshold. So I could do data bigger than threshold, like this. And then I kind of want to get like the index of the first true in this list. So this, and so on and so forth. So there are a couple of different ways I could approach this. I think the way the hint revolves around is that I do argmax, and then I pass 1 here, because I want to compute a non-dense dimension. So what's that going to do? Well, here you just have to know that argmax will always select the first entry where the condition is true, because like the maximum could be this entry, that's 1, that corresponds to 1, and this also corresponds to 1. So it's a little bit arbitrary which of these indexes, the index of which of these maximum elements it selects, but it will select this one. And as far as I know, I think it does. That's verified. So I'm just going to I'm pressing Control to look at the documentation. I'm clicking on it. Then we can see the documentation here. So it's the index of the maximum element. Let's see. Yeah. So if there are multiple occurrences of the maximum element, that is, there are multiple values that are 1 or true in this case, it will return the first occurrence. So it will return this index. So we can verify that, and it does, and it kind of does the right thing. This is like super nasty. I think this is very unintuitive, and I would be a little bit scared about this code because I mean, okay, so it works, but you know, is it the first it returns, or is it something else? Is it arbitrary? It's a little bit nasty. Another way of doing it, since these lists appear to be growing, we could count how many false there are in the list, and that would also give us the index. So another way of doing it is that we can get all the values that are like we can check when it's larger than the threshold, then we can see when they are false, and then we can actually sum these together. We could also just compare if it was less than or equal to the threshold along the first dimension. And that will also actually get us the right list. Because now we are like summing these two together, and that's 2, so we get a 2 here, and there are 5 trues here, so that gives us 5, and that would also work. So that's another way of solving it. But I mean, personally, I think this is a little bit nasty. And the bottom line is that if you want to do elegant stuff like this, if it's like important for your application to do something like this where it's super efficient, what I would always recommend is that you first implement this silly slow version that I have here, and then you compute B, let's call it B numpy, which is like your highly optimized numpy solution that looks like this. And then you compare the two. So now I'm just going to run all of this code. Oh, indentation error. I'm going to select all of it, Shift Alt V, B. And let's see if they're the same. Oh, I didn't run this line here. Oh, it's because I spelled it wrong. It's false. So it's not the same. So it doesn't even work. Oh, that's because maybe it should be greater than or equal. Now it still doesn't work. So maybe it's because these data entries are not always increasing, because in that case this doesn't work. So let's go back to the argmax idea. Yeah. See, this is why testing it is important. But I mean, so here we got the alternative version, and let's try to compare the two again. With the right spelling, and now it works. Yeah, okay. So this doesn't work because this idea relies on, like, it relies on the data entries always increasing in size. Because if they don't increase, you can have like some, like this condition can be, this condition can be like true, true, false. We want to get the index of the first false, but then there can be other true values later. And then when I compute the sum, I'm like getting two large numbers. So it doesn't work for that reason. But it wasn't apparent from just looking at this subset of data, because here it looks like it would actually work. So this is, I think this is the, I think there are other ways of doing it where we modify data, but I think this is the only one-line solution that I can think about at least. But it's like really complicated in my opinion. You'd almost have to torture me to avoid me writing code like this, because it's like just so much. It's in my opinion it's clear what this code does, but your mileage may vary. But let's return the elegant solution, the cool solution. Silly, but okay. I know what it does. Okay. So I think that's all I have to say about this exercise. So sorry, I know that I messed this one up a little bit, but I think this is fine. It's slower, but I mean, slower is often something that's measured in milliseconds, and figuring out how to do this is measured in minutes, and there are a lot of milliseconds in a minute. So you be the judge of which approach you generally prefer. But thanks for your attention.